Hello, math students. Welcome back. Module 1, Ratios and Unit Rates. The lesson title for this lesson is Comparing Ratios Using Ratio Tables and Double Number Lines, and this is Lesson 7. Our goal for today we are going to learn how to compare ratios on ratio tables and double number lines. The question that I want you to be thinking about during this lesson is, how do ratio tables and double number lines show a comparison? And in quotes it says show. So that means, what does it look like, or what can we see? All right? Things to learn. Ratio tables contain equivalent ratios that sometimes must be compared. So we have two ratio tables here. Remember, these are called ratio tables because it's giving you some information that you're comparing. In Amy's ratio table, we're comparing drops of lemon juice to cups of water. So for every 8 drops of lemon juice, you need 2 cups of water. 16 drops of lemon juice, you need 4 cups of water. 24 drops of lemon juice, you need 6 cups of water. And for 32 drops of lemon juice, you need 8 cups of water. That's Amy's table. In Rachel's ratio table, it is drops to lemon juice, drops of lemon juice to cups of water, except her ratio is different. Hers is 15 drops equals 3 cups of water, 30 drops equals 6 cups of water, 45 lemon drops equals 9 cups of water, and 60 drops of lemon juice equals 12 cups of water. So there's both girls' ratios tables. Now, the thing that I want you to look at on both of the tables is, what do these tables have in common? Well, basically, the things that they have in common is they both are comparing drops of lemon juice to cups of water. Drops of lemon juice to cups of water. So we're going to write that. What they have in common is that they are comparing drops of lemon juice to cups of water. That's what they have in common. Both of them have those. Okay? Comparing anything else? Ooh, I see something else that they can compare. Okay? Why do you think I starred these? Okay? If you said that it's because Amy uses 6 cups of water and Rachel uses 6 cups of water, except the difference is on Amy's 6 cups of water, she only needs 24 drops of lemon juice, and on Rachel's 6 cups of water, she uses 30. So that's something else that we could compare. Okay? Could you determine how many drops per 1 cup of water? So we can answer that question by saying yes. Remember, this is drops of lemon juice, and this is cups of water, and this is drops of lemon juice, and this is cups of water. And then we're going to take Amy's is 8 to 2, and Rachel's is 15 to 3. And now it's saying, could you determine how many drops per 1 cup of water? So cup of water side is going to be the 1, just like we talked in our last lesson how to do that. So the question is, how do you get from 2 to 1? We've talked about this in class. Multiplying or dividing? Well, if you divide by 2, 2 divided by 2 equals 1. What you do to one side, you have to do to the other. So 8 divided by 2 is 4. And then on this side, how did we get from 3 to 1? Divide by 3. What you do to one side, you have to do to the other. So 15 divided by 3 is 5. So in Amy's, for every 1 cup of water, she needs 4 drops of lemon juice. And in Rachel's, for every 1 cup of water, she needs 5 drops of lemon juice. Okay? And so we did figure out how much per 1 cup of water. And then the next question says, who uses more lemon juice in their lemonade? And if you're looking at it, 1 cup takes 4 drops in Amy's, 1 cup takes 5 drops in Rachel's. So who uses more lemon juice in their mixture? Rachel uses more drops by 1. And the reason why we say by 1 is because Rachel uses 5, whereas Amy uses 4. So 5 is 1 more than 4. So Rachel uses more drops by 1. Okay? All right, so now the next thing that we have to do is it says, now you try. A liter bottle of cola contains approximately 34 fluid ounces. How many grams of sugar would be in a liter bottle of cola? All right, so here's some important information that you need to know. There are 20 grams of sugar in 6 ounces of cola. So again, we're comparing grams to ounces, and it's grams of sugar to ounces of cola. All right, and the first thing that it tells us to do is make a ratio table. So for every 6 ounces of cola, there are 20 grams of sugar. Every 6 ounces of cola, there are 20 grams of sugar. Okay, so we're making a ratio table. And something that I would like to propose that you do is we've got to get some data points on here. And so the first one that I would like to try to do is, what happens if you are trying to figure out in 1 ounce of cola? Okay, how about if we're figuring out 2 ounces of cola? How about if we're trying to figure out 3 ounces of cola? Okay, how many would we do if we were going to do 12 ounces of cola? How many are we going to do if we are going to do 18 ounces of cola? And maybe how many would we do if we were going to do 24 ounces of cola? Okay, so that's what we're trying to figure out. And what you're going to do each time is you're going to figure out what we have to increase or decrease the amounts by. So the first question that you ask yourself, just like we did on the lemon drops one, how do you get from 6 to 1? Well, in order to get from 6 to 1, we're going to divide 6 by 6. What you do to one side, you have to do to the other. So since we did 6 divided by 6 to get 1, we're going to do 20 divided by 6. And 20 divided by 6 could look like this. Okay? Now, how do we get from 6 to 2? You're going to divide by 3. So what you do on one side, you have to do the other. So this one would be 20 divided by 3, right? How did we get from 6 to 3? We divided by 2. So what you do to one side, you have to do to the other. So 20 divided by 2. And then how did you get from 6 to 12? This is where it changes. How do you get from 6 to 12? We multiplied by 2. What you do to one side, you have to do to the other. So we're going to take 20 times 2. Okay? And then how did you get from 6 to 18? We did 6 times 3 equals 18. So what you do to one side, you have to do to the other. So we have to do 20 times 3. And then the last one, how did you get from 6 to 24? We multiplied it by 4. So what you do to one side, you have to do the other. And so if you see, we have a couple of patterns going on. If the numbers of cola are smaller than 6, then we divide. If the numbers of cola or the ounces of cola is larger than 6, then we multiply. So let's go ahead and do that. 20 divided by 6 can simplify. If you have 20 divided by 6, you can simplify that by making it 10 thirds, right? And then we know 3 goes into 10 3 times with 1 left over, so it would be 3 1/3. Okay? Now you're going to do the same thing here, where you have 20 divided by 3, right? And 20 divided by 3, 3 goes into 26 times with 2 leftovers, so the answer would be 6 2/3. Okay? 20 divided by 2 equals 10. That one wasn't so bad. 20 times 2 equals 40. 20 times 3 equals 60. And 20 times 4 equals 80. So in this box, the answer to this one is 3 1/3. In this box, the answer is 6 2/3. In 3 was this box, your answer was 10. And then 12 times 2 is 40, or not 12, 20. 20 times 2 is 40. 20 times 3 is 60. And 20 times 4 is 80. So now you've created this table that helps us see it. Okay? And so, does the ratio tell you the answer? says there are 20 grams of sugar for every 6 ounces of soda. A liter bottle of cola contains approximately 34 fluid ounces. Do you see 34 anywhere up here? And the answer is no. So we're going to say no. But could we find the answer? Yes. We need to compare more amounts. Okay, so we can do that. Make a double number line. And the way that you make a double number line is a double number line just shows two amounts happening at the same time. So if I have 0 ounces of cola, then I have 0 ounces of sugar. Okay, if I have 6 ounces of cola, then I have 20 ounces of sugar. If I have 12 ounces of cola, then I have 40 ounces of sugar. If I have 18 ounces of cola, then I have 60 ounces of sugar. If I have 24 ounces of cola, then I have 80. If I have 30 ounces of cola, then I would have 100 ounces of sugar. If I have 36 ounces of cola, then I would have 120. If I have 42, then I would have 140. And if I have 48, then I would have 160. Okay? Now, the question, however, said how many ounces or how many grams of sugar if there are 34 ounces of fluid, or 34 fluid ounces of cola. Well, if you look at our double number line, what we did is we went 6 to 20 was our original ratio. And then this one from here to here was times 2, times 2, times 3, times 3, times 4, times 4, times 5, times 5, times 6, times 6, times 7, times 7, times 8, times 8. So you have to remember that rule of what you do to one side, you have to do the other. But here's the problem. We need 34. Here's 30, here's 36. So 34 actually sits about here. So if we're trying to find 34, we actually need an easier way to do this. And so one thing that I suggest that you do is you go back up to our table above, because we found, if you remember, how many grams of sugar there were when there was 1 fluid ounce. So come back up here to 1, and what did we find? 3 1/3. So this is 3 1/3 for 1 fluid ounce. So then the question is, how do you get from 1 to 34? And the answer to that question is you multiply by 34. Because 1 times 34 is 34, yes or no? Okay, what you do to one side, you have to do to the other. So we're going to take 3 1/3 times 34. Now, some of you are going, oh my gosh, Mrs. Nelson, I can't remember how to do that. Well, if you have 3 1/3 times 34, what that really means is you have 3 holes, right? Here's a hole, here's a hole, here's a hole. There's 3 of them. And then you have 1/3 of the next one. So you only have this, right? So this picture represents what we have, okay? But what that means is you're multiplying it 34 times. So I don't know about you, but I do not want to draw it 34 times. So what I want to do instead is I want to count what I have. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I actually have 10 thirds. Does everybody see how that's 10 thirds? I just counted them. Then we're going to multiply that by 34. And the way you turn 34 into a fraction is you have a denominator of 1, because 34 divided by 1 is still 34. And now, because they're both fractions, I just multiply straight across. So I'm going to go 10 times 34. So here's 34 times 10. 0, 0, placeholder, 4, 3, add them together, and we get 340. So this is 340 divided by 3 times 1 is 3. All right, so we're almost there because we actually have to finish this. This is actually a division problem. So it says 340 divided by 3. Okay, not bad. So that would be 1, 0. I'm not going to write a 0 because I want to make it as clean as I can without extra numbers. So then you bring down your 4. 3 goes into 4 one time. Okay, subtract. I get 1 left over. Bring down the 10, so that goes in 3 times, which is 9, with 1 left over. And remember, your leftovers are your numerator, your denominator is the number at the door. So for 34 ounces of cola, there are 113 1/3 grams of sugar. So you've just figured out the answer to the question. Okay, so looking up here, a liter bottle of cola contains approximately 34 fluid ounces. How many grams of sugar would a liter bottle of cola have? Did we just figure it out? The answer is correct. So you got 113 1/3 grams of sugar. And do you see how the double number line helps you get the answer off of there? And if you do, then that means that you understand the double number line. Okay? We're going to have lots of practice problems with both of these. And so the double number lines are going to be actually a really cool and fun tool that helps us. So far you have learned about ratio tables. Here are ratio tables, and we need to compare with them. And then you also learned brand new information about a double number line. And the double number line, I have to be honest, is my favorite. So let's go back to our goal for today. Today we are going to learn how to compare ratios on ratio tables and double number lines, which we just did. Here's how we compared them on the ratio tables. Here's how we compared them on the double number lines. Okay? And then the question that we asked in the lesson was, how do ratio tables and double number lines show a comparison? Ratio tables, they can show a comparison as long as you have something that is the same. Then that's how you can see the comparison. 6 cups of water, 6 cups of water, 30 drops, 24 drops, so you can see the difference between the two. On the double number line, the way that it shows the comparison is it compares one item to the other, and you can actually visually see the comparison. For every 6, there are 20. For every 1, there are 3 1/3. For every 34, there's 113 1/3. For every 18, there's 60. For every 48, there's 160. So it's a very cool tool to see everything and do a comparison. All right, kiddos, that's all I have for you on this lesson. I hope you enjoy. Talk to you soon. Bye.